Good afternoon. We are on the 10th day of chapter 2, which is the second day of content 2.3. We're going to talk about positive and negative intervals. So you will need graph paper for these notes. If you don't have graph paper, grab some. You also need a ruler. Okay, so Roman numeral 1, what are positive and negative intervals? So first one, a positive interval on a graph are values of x at which y is greater than 0, and y can't be 0 and be a positive interval. So the interval is the location where y is a positive number. So a negative interval is similar. It is values of x at which y is less than 0. And again, y can't be exactly 0 and be on a negative interval. And an interval, when you give an interval, you're giving a minimum and a maximum pair of x values. And most of the time when doing the interval, the endpoints are excluded because typically that's where y equals 0. Okay, so we're going to do an example. So draw a graph on the right-hand side of your paper. It's a pretty simple graph. And we have a line that's going to cross at 1 and cross at -3. And this is a rough drawing, so it's okay if it's not exact. Looks like a parabola opening downward. So on your homework, the first thing they're going to ask you for are the zeros of the function. The zeros of the function are where y equals 0. So there are two places here and here where y equals 0. Those are the zeros. So the notation for that is roster. X is an element of the set containing -3 and 1. That's where my zeros are. Okay, so then the next thing they're going to ask you for is your positive interval, which is where y is greater than 0. So I'm going to use a highlighter here. So here's my y-axis. So anything that's up above the origin is greater than 0. So this interval is from here to here, excluding the endpoints, because we don't want where y is equal to 0. We want where y is positive. So those endpoints are not included. So using interval notation, this interval from the x's goes from -3 to 1 exclusive. So use parentheses, -3 to 1. Between those x values, we have a positive interval. Okay, now negative interval, which is where y is less than 0. So on this graph, y is less than 0 here on this piece and here on that piece. So for that one, there's two separate pieces we're going to need to use union notation. So for the left piece, it goes from -infinity up to -3, not including the -3. So -infinity up to -3 in union with, and then this piece starts just after 1 and goes to positive infinity. So 1 to positive infinity. So two pieces are always separated by a union symbol. All right, let's do another example. I'm going to turn the page here. So example 2. So go ahead and draw a quadrant 1 graph. We're not going to use the other quadrants. And let's say that we have a vertex at 3, 1 and a parabola that's opening upward. Okay, so first thing you're looking for are zeros. This does not cross the x-axis, so there are none. There are no x-intercepts or zeros. Okay, now positive interval. Positive interval is where the graph is in the positive y region, which is actually the whole thing. The whole thing is in the positive y area. So for our positive interval, it's negative infinity to positive infinity, since the whole thing is in the positive y area. So for negative interval, there is no graph down here in the negative y interval, so that is none. Okay, let's do another example now. Example 3. This one we actually have an equation for. So the equation is y equals 3x squared minus 5x minus 12. So in order to figure out where it has a positive interval or a negative interval, we need to know, where does it cross the x-axis? Because that is the division between the positive and the negative y values. Okay, so we need to find the x-intercepts. And if you remember, x-intercepts are always some number a comma 0. So we replace y with 0. And then you factor. If it doesn't factor, you use quadratic formula or completing the square. This one does factor into 3x plus 4 times x minus 3. So solving that out, we get x equals negative 4/3 and x equals 3. So over here on the right, this wouldn't be like a formal graph, but you would want to sketch a little tiny graph so you have a visual of what's going on. So I have a parabola that's crossing at 3 and negative 4/3, which is like 1 and 1/3, so somewhere about there. And my a is a positive 3, so I know that my graph is opening upward. And I don't really care where the vertex is for this. Okay, so if it's asking you for the zeros, you can give your zeros in the form of roster. So x is an element of the set containing negative 4/3 and 3. If it asks for intercepts, then you'll give the coordinate form of it. But there's my zeros. Okay, so now we want the positive intervals where y is greater than 0. So y is greater than 0 on this piece and on this piece. We do not include the endpoints. So we're going to end up with a union symbol because we have two pieces where y is greater than 0. So the left piece is negative infinity because of the arrow up to negative 4/3. So negative infinity up to negative 4/3 in union with, and now we do the right piece. It's from 3 exclusive up to positive infinity. So 3 to positive infinity. Okay, so the last interval we need is the negative interval, which in this graph is this piece right here. That's where y is less than 0. And it's just one piece, so we can use the interval notation negative 4/3 exclusive up to 3 exclusive. So that's how you work with an actual equation to find the zeros. Let's do one last one like that. And then that will wrap it up for today. So example 4 is y equals negative x squared minus 15x minus 56. Okay, and we want to first find the zeros. So remember, your zeros are your x-intercepts. So let me put in here, we're going to find positive intervals, negative intervals, and here we're going to do our math. So if to find the zeros, we set y equal to 0. And I'm going to go ahead and divide a negative off there. I just don't like negative a values. So I'm going to put the negative out front, x squared plus 15x plus 56. This actually does factor into x plus 7 times x plus 8. The negative does not contain an x, so we can disregard that factor and just do the 7 and the 8. So x is negative 7 and x is negative 8. So my zeros, x is an element of the set containing negative 7 and negative 8. Okay, so let's do a quick little sketch of our graph. I'm going to put my y-axis way the heck over to the right. So I have a 0 at negative 7. Let's say it's right there. And a 0 at negative 8. My a value is a negative 1. So my parabola is opening downward. Like that. Okay, so positive interval. Well, y is greater than 0 is here. excluding the endpoints. So it's between -8 and -7. So that's our interval, -8 exclusive up to -7 exclusive. Now, the negative intervals include this branch and that branch. So we're going to use a union symbol again. So -infinity up to -8 in union with -7 up to +infinity. And that includes both branches. Now, don't forget that when you're giving intervals, intervals are x values, not y values. The y values are what designate positive and negative intervals, but intervals themselves are always the x values. And that's a really important concept to keep in mind when you're working with these. All right, that's the end of the notes. I hope that helps. Have a good rest of your day.